Why are most perfect magic squares unique? Imagine a puzzle where every number has a perfect place and all the lines add up to the same total. That's what a magic square is all about. But why are most of these squares, especially the perfect ones, so unique? It's a question that sparks curiosity in anyone interested in numbers and patterns. Let's start with the simplest case, the 3x3 magic square using numbers 1 through 9. This tiny grid has a special property. The total for each row, column, and diagonal must be 15. Because of this strict rule, only one basic pattern exists, and all others are just rotations or reflections of it. This means that, in essence, there is only one fundamental way to arrange these numbers to make a perfect magic square. When you increase the size of the square, the number of possible arrangements grows. Still, many of these larger perfect magic squares are very limited in how they can be built. That's because they must follow the same strict rules about sums and placements. For example, some special types of magic squares, called most perfect magic squares, have extra conditions. These conditions make them even rarer and often unique for their size. They might requiring all 2x2 blocks to sum to the same number, which narrows down the options even more. Now, if we look at magic squares made of perfect squares, numbers like 4, 9, 16, things get even trickier. It turns out that a 3x3 magic square with 9 different perfect squares simply cannot exist. The reason is that the extra rule of using only perfect squares limits the possibilities so much that solutions are impossible or very rare. So, why are most perfect magic squares unique? It all comes down to the fixed magic sum, the many constraints from the sums in different directions, and the special properties of the numbers involved. These rules create a system of equations that only a few arrangements can satisfy. Because of this, most perfect magic squares are either unique or have very limited variations. They are like hidden gems in the world of numbers, showing how perfectly balanced and harmonious mathematical patterns can be. These squares are more than just puzzles. They reveal the deep order and beauty that numbers can hold. Their rarity and uniqueness reminded us that even in chaos, there is a pattern waiting to be discovered.